Okay, so 13.3 geometric series, and we need to look at how to find the sum of a geometric series. So going back to the example for music, so we have a real life example, so real world example. So there was a music question at the beginning of the lesson that said about students sending emails, and each student would then send further emails. So we're told that 5 emails are sent in the first round. We are told that each student who receives an email sends 5 emails. And this continues, so the pattern continues until the 8th round. So we need to find out how many emails will be sent in the 8th round. So to do this, we're going to use the sum formula. So there are 2 formulas. So the first one, if we know the first term and the number of terms, we're going to use this formula. So we're given A1 and N. So we're going to use this formula, which is Sn is A1 minus A1 multiplied by R, the ratio, to the power of the number of terms, and this is divided by 1 minus the ratio. So this is our formula for the sum formula for geometric series. So we need to substitute in values. So let's write down what we know. So the first round is going to be 5 emails. So we know that the first number is 5. The ratio, each student sends 5 emails. So the ratio is multiplied by 5, so it's going to be 5. We also know that the last round is going to be 8. So N will be 8. So we're looking at stopping at the last number. So I'm going to substitute in my values. So A1 is 5. So it's 5 minus 5 multiplied by the ratio, which is 5, and N is 8. And this is divided by 1 minus 5. So we're looking for the sum of 8 numbers. So we can write as S8. And if we work out the numerator, this is going to be minus 195320. And the denominator, 1 minus 5, is minus 4. And I'm just going to put that into a calculator. And we will have 488,280. So this is 488,280 emails sent in the 8th round. So the guided practice, we have 2 questions, and we're asked to find the sum of each geometric series. So pause the video, have a go, and when you're ready, press play. So we'll look at 4a. So I'm just going to rewrite the question. So A1 we're told is 2, the number of terms is 10, and the ratio is 3. So if we're given A1 and n, we can use this sum formula, which is A1 minus A1 multiplied by r to the power n divided by 1 minus r. And this is when r is not equal to 1. Otherwise, we will have an undefined value on the denominator. So let's substitute in the values we know. So the sum of the numbers, so A1 is 2, so 2 minus 2. The ratio is 3. And the number of terms we're told is 10, so to the power of 10. And the 1 minus 3 on the denominator. So we're just going to calculate the numerator. So we have 2 minus 2, 3 to the power of 10. So this is 59049. And this is divided by minus 2. And I'm just going to put these values into my calculator. And I will have minus 118096 divided by minus 2, which is 59,048. Okay, and 4b, I'm just going to rewrite the question. So we're told that A1 is 2000, AN, so the last term is 125, and the ratio is a half. So we're given, this time, A1 and AN. So if we're given A1 and AN, we need to use the other formula. So given A1 and AN, we're going to use the formula Sn. Sum of the numbers is A1 minus AN multiplied by the ratio divided by 1 minus the ratio. And I'll substitute in the values. So the sum of the numbers, A1 is 2000. The last term is 125 and the ratio is a half. And this is divided by 1 minus a half, or 0.5. So the sum of the numbers is 2000 minus 62.5. And that is divided by, so that's 1 minus a half is a half. Or I'm just going to write 0.5. And I'm going to put this into my calculator. And I have 3875 as my answer. So it's 3,875. Okay, so we're going to look at example 5. And this is when we're given the sum in sigma notation. So you'll see this like large E. And the number, we said we met this last time. So we have the 10 on the top. And the first term, so k is 3. And we're given a formula. So we're given 4 multiplied by 2 and 2 to the power of k minus 1. So we need to find A1. And we need to find the ratio. And we need to find the number of terms. So the first one, A1. So k is 3. So our first value is going to be 3. But we need to put the 3 into the formula. So this is going to be 4 multiplied by 2 times 3 to the minus 1. So this is going to be 4 multiplied by 2 to the power 2, and that is going to be 16. So A1, our first value, is 16. The ratio is the base value. So the ratio is the base value. So this is going to be 2. So this is our value here. So we've got 2. So the next one we need to find is n. So to find n, this is going to be the difference between the top value and the bottom value. So that's 10 minus 3, and we add 1. So that's going to be 7 plus 1 is 8. So we've got the number of terms as 8. So we're going to put this into our formula. So Sn, so I'll just write this by here. So Sn is equal to A1 minus A1 R to the n divided by 1 minus R. So the sum of our numbers, so A1, the first term is 16. So 16 minus 16, our ratio we said is 2, and the power n is 8. So the sum of the numbers, if we work this out, we will have 16 minus 16 times 256 divided by minus 1. So the sum of the numbers is going to be minus 4080 divided by minus 1. The minuses cancel, so we're left with 4080.